tricky, but. All right, so we are determining a minimum sample size. Let's think about last chapter, or not last chapter, before the quiz. When we're dealing with means, our margin of error equals what? Symbols, letters, stuff. All right, well, not much of that's going to change. We're still dealing with margin of error. Are we still dealing with Z? And again, why couldn't we use T? But why couldn't you actually solve this problem? Yes, correct. But why couldn't we solve this problem with means with T? Because what are we solving for? And what do you need to find T? So you can't use a T there because you need N to find it, and we're solving for N. So here, what's this part going to be? So this is the equation we're using instead. Now the square root was on the bottom here, and now it's over all this. So it looks a slight bit different when we do the algebra to get out of it. Now, this is the class that's actually asking me last time, why don't we move this first before we multiply here? And we didn't need to because we just divided it in Z back over. What's my first step now with this one? I actually do have to move this first. Why? Because it's not under the square root, so to get rid of it, I'm going to have to do it that way. So algebra steps here, multiply both sides, or divide both sides by Z. So right now I have margin of error over Z equals square root of P hat, 1 minus P hat over N. So now my next step is what? So when I square both sides here, that cancels with that. But this is squared. And then what from there?
You can do the reciprocal.
Yeah, which, and I'm fine with you going straight to there. Fine with the issues with algebra. So at this point, I've got N times this equals P hat times 1 minus P hat. So now I want to move this over. So my final is going to be the N. What does my inequality end up being at the end? Because I'm solving for N, minimum sample size, I need that my lowercase n is. And then what's going to be left over there? What's on top? And then what's on bottom, that whole part is squared. So you can go through the process of algebra every time, or memorize that, and I don't care, just like before, I don't care which one you do. All right, so our next example, I want to skip down to number 4. Yeah. So 4A, how large sample is required to obtain a margin of error of 0.03 in a 99% confidence interval. So since we just went through all the steps of algebra, let's just go ahead and write it that way. So p hat times 1 minus p hat divided by what's in our denominator? So I'm going to plug in my numbers here. National opinion poll found that 44%, well, 44% is going to be my what? Agree the parents should be given vouchers that are good for education in any public or private school of choice. The result was based on a small sample. What's the other thing this one gives me? Which is actually the question. My confidence level and what else? So I don't really plug in 99%. I plug in the Z for 99%, which is what?
2.56.
So now I'm just plugging in my numbers. P hat is 0.44. So 1 minus p hat is what? And then I'm dividing that by 0.03 divided by 2.576. That part's squared. And what do you get as your answer? And I don't mind if you're taking time to write this down, but I definitely want everybody to type this in to make sure you're typing it right. Because this is just one of those like weird finicky things where you could mess up the way you're typing with parentheses and get it wrong.
1816.73.
So it would round up to 1817. You end up getting 8. Now keep typing it in, but you get like 1,816 point something. Well, that wouldn't be enough. So our answer has to be, so it's and if you're not typing that right, it's a whole lot easier to deal with that now than deal with that later. Now, we are trying to figure out the smallest number we can sample and still be within a given amount, right? So am I okay if I sample less than that? No. Am I okay if I sample more than that? Yes. So if I have to be wrong, would I be wrong by sampling too many people or not enough people? Too many. Because if I'm sampling too many, I've covered enough. So thinking theoretically here, I'm multiplying p times 1 minus p up here, right? Everybody's with me on that? All right, so let's think about different options. So if we have a p hat of 0.1, our 1 minus p hat would be what? 0.9. If we had one, so let's think really small. What about like 001? What would our 1 minus p hat be? How many nines? All right, so let's think about what these give us. What does 0.1 times 0.9 give us? What does this times this give us? How many zeros? Three zeros and then 3 nines, is that right?
Yeah.
So if I take a really small number here, I'm gonna get a really small number when I'm multiplying, right? So if I think on the other end, what if I take a big number? Well, if I go all the way to 0.9, what would happen there? That's the same thing, right? So what's the biggest combination I could possibly do? So you're gonna do 0.4 times 0.6, which is the same as 0.6 times 0.4. Y'all with me there? So what's the biggest combination? 0.5 and 0.5. Which so that is the biggest one I could possibly get.
No, that was
That's all.
sorry.
This is the biggest combination I can possibly get, right? So if I have no idea what my p hat is, and I need to figure out how many people I need to sample, and I need to make sure I sample enough people, what should I put in as p hat? 0.5, so it's going to give me the biggest combination. So that's where it says right here, you can either use a p based on a pilot study, which is like the one we just did, or you use p equals 0.5 if one is not given. So this problem right here, and I would write something like so with this one, a margin of error no greater than 4%. So that's telling me my what? My margin of error equals what? Because 4% is a decimal, is 0.04. 95% gives me a z of what? And that's all this problem gives me. So I'm using my same equation. So now I'm plugging in p hat is 0.5 divided by what goes here? Numbers. What number is going to go right here? Divided by, and that part is squared. And we end up getting so using t equals 0.5 is our most conservative approach. So if we don't know what p is, in order to make sure that we get enough to be correct within that margin of error, we would use a p hat of 0.5. So kind of like when they do polls for politics, they would probably use 0.5 because they want to make sure that they're correct within that margin of error. That would give us exactly how many they need to make sure they sample. Questions on solving for minimum sample size? Honestly, probably the most